Nobody likes them, but everybody needs them. I'm talking about software updates for embedded systems. In the webinar that we created with Phytec, we talk about future-proof IoT systems. They need to have software updates, they need to have a secure hardware, but they also need to have a way how to update these devices securely. So secure meaning hacker-proof, but also safe in a way that these devices will not get bricked, or if they have any problem, maybe power outages, internet outages, that they will always come up seamlessly in a fallback system. What open source components you can use to have such a great system, I will explain in the video, as well as other update topics like requirements, other techniques, and so on. Enjoy the webinar.
I'd like to welcome you to our webinar, Future-Proof IoT Platforms, Secure Hardware and Device Management with Phytec and OSB connagtive. Today, Phytec is presenting OSB connagtive as their partner for update and device management solution. The IoT-Device-Suite is developed by OSB connagtive. And so we're going to show you around. In the beginning, we're going to introduce Phytec real quick. I'm going to quickly skip over that and make it as short as possible because we have some cool, interesting stuff. And then I'm going to explain explain a little bit the concepts of secure devices in the embedded world. How do you secure your device? Yes, those are based on our offerings, those explanations. And then I will pass on to Roland, who will introduce IoT Connagtive Device Suite and also the company, of course. And he will also show some concepts, technology in terms of update and device management, and then show his solution in a live demo presentation, how the IoT device suite handles all these update and device management tasks that are required for embedded devices. So let's get started. My name is Yves Astein. I'm head of product management at Phytec Messtechnik. I'm responsible for all standard products in terms of SOMs, system on modules, and single board computers, as well as all the software infrastructure around these products, including the operating systems, as well as the features within the operating systems in middleware and so on. And I'm responsible for partner management. And Roland is the director of IoT and embedded security at OSB connagtive. He is the father of the today presented IoT suite, and also part of the development team, head of the development team that has developed this platform.
Hello, also from my side.
Hello, Roland. So Phytec, just a quick introduction of Phytec. 35 years we've been in the business, even over 35 years. We have our headquarters in Germany, including the production for all of our products. We have more than 400 employees globally, and we will have a revenue of around 70 million this year. We also have subsidiaries in France, US, India, and China. Our main products are system on modules, of course, and the applicable carrier boards. We call them single board computers, which are also series ready. And we have OEM products, which are, for example, gateways that already have housing and are ready to use. They're white labeled, so anyone can purchase them and label them as they like and use them for their application. And we have full customization of hardware where we develop the full hardware, including housing, if this is required. We have a broad spectrum over all embedded devices or embedded processors that are typical on the market today, starting with NXP as one of our biggest partners. We have a big portfolio of their processors supported on our SOMs. Future products, IMX9, for example, the high runners, IMX8M Plus and IMX8M Mini, most current. But this goes down to history to IMX27, so very old products that we are still producing today. With TI, we also have a long history, and we are starting 3 new products right now. 2 are already available, and 1 will be available at Embedded World. And we also have a growing portfolio with ST, STM P1, and future MP13. Typically, when you purchase a system on module kit from us for evaluation purposes, you will see that you will get the system on module in the middle, stuck on one of these carrier boards. These are our single board computers. As I mentioned, they are ready for series use, or they can be used as a reference design. We provide the schematic to this. So if you want to design your own carrier board, you can do this based on this reference design, or we can modify these as well. I will show you later. There will also be add-on adapters for cameras, for RF modules, Wi-Fi, Bluetooth, and other RF technologies, sub-gigahertz, for example, displays, and camera boards, and so on. So there's a lot of add-ons available. Of course, everything comes with a board support package. Typically, it's Linux, but also Android, FreeRTOS, QNX, VxWorks, and many more. And in these board support packages, we support software services like Azure Cloud Access, machine learning, over-the-air updates, and so on. So a lot of middleware that we also support. When it comes to customization of hardware, we have a service where we can customize existing carrier boards for you according to your requirements. These are small changes to a board, remove interfaces or add interfaces, but the form factor will most of the time stay the same or maybe be a little bit reduced, but small changes. And these can be done in very short time, 6 weeks in average, until we hand over the final product. And yes, this is for lower volumes, and the cost is quite good. And so if one of our boards fits your application almost, then we can talk about modifying it the way you need it, or a full-on design services, which is then a carrier board design for according to your requirements with specification and so on. Average is around 12 weeks of development time, and yeah, volumes higher than 1K is typical, and pricing starts at 10K. Depending on the complexity. Phytec offers a lot of solutions, full spectrum. We have our products, the system on modules, as I just explained, embedded imaging kits, where we specialize in imaging. We have our special department for imaging topics, with 3 specialists focusing on this topic. We have our design services, as I just mentioned, coming from integration, custom hardware to bring up, and mechanical 3D design of housings. The manufacturing, which I mentioned, is in-house with prototyping and everything. The logistics that we offer, and lifecycle management up to 15 years or longer. So we actually have products in our portfolio that are still being sold that are older than 30 years. So we do not discontinue a product if we don't have to. If the processor is still available, then we can provide the product, and we maintain those products for a long time. That's very important for our industrial customers. But on top of this hardware that we sell, we also try to identify added values on top in terms of middleware. So, for example, the embedded vision topic with hardware as well as also software features that we prepare for our products. Update and device management, which we are going to talk a little bit more. Security is a big topic now. Edge cloud computing, AI, and voice recognition are some of the topics that we've identified that are being used by customers a lot. So we prepare this in order to reduce effort for the customer. Now going to the main topic, embedded security. Typically, when you're talking about update and device management, you usually do it for security reasons, but you also do it maybe for updating your device for new features or for bug fixing. But here we're concentrating on embedded security. Yeah, so we have a team that has specialized in consulting and preparing features in the BSP for security. We can do software lifecycle management, and we help you protect your know-how, be compliant to legal obligations that you might have, and we can protect your device against misuse. We can help you with device networking and secure data acquisition and storage. So typically we provide our Linux operating system to our boards, as I mentioned earlier. And yes, so everything, middleware and low-level drivers are already adapted and prepared. So the green box symbolizes what we offer to you. And the customer can then, according to the yellow box, add his application on top of our operating system. And within our operating system, we've prepared all the security features, like public key infrastructure, secure boot, secure storage, network features, and access privileges, and everything is already prepared and ready to be configured according to your need. So that's the most important part to get your system secure is secure configuration of your embedded device with all these just mentioned features. But so your system is now secure, but what about tomorrow? If you want to make sure that your device is not just now secure, but for the future also, you will have to maintain your BSPs because there will be vulnerabilities coming up. And therefore, you will need a maintained BSP. You will need to probably monitor the whole thing with CVEs, looking at the common vulnerabilities that are known and check them against your BSP if they are within this BSP and if you're affected by those. And then if you identified these problems and you fix them and you need to update your system, you need a possibility to upload those updates to your edge devices. And for updating devices, you will probably need provisioning because that will enable you to authenticate your device to your update server and then get a connection to it. So today we're going to mainly talk about the update and device management, but I'm going to show you real quick the methods that we chose to keep our Linux BSP up to date and secure. This is typically, if you look at this, this is the mainline. This is supposed to resemble the Linux mainline. And Linux mainline generally creates LTS updates on a regular basis. And these are then feature frozen and then continuously maintained by the community with bug fixes and security fixes. And this is a good way to use these releases because they are stable from a functional perspective, but they are still being maintained in terms of security. And we take these LTS releases and we make the required adaptations so that the Linux will run on our boards. And we test them and provide them to our customers who then can add their application and do final tests and deploy. And we continuously do this to each LTS release on a nightly basis with an automated CI system where our boards are in a test station continuously updated with the new LTS patches and then continuously tested. So this is a pretty good basis to always have an up-to-date LTS release for your device. And we can actually offer also customer-specific software lifecycle management, where we do the same thing, as I just explained, not for our boards, but for the boards of our customers. So we can add your carrier board into our CI testing system, and then we can talk about the test requirements that you have, the features that you need to have tested, and we will then create tests for that and continuously test your board with newest LTS releases and also with the newest major releases of Linux kernel. So this is a pretty cool offering for an overviewable price, I think, and it helps you keep your software up to date according to what is needed in terms of CVE testing, for example. And this is the next topic, CVE testing. We recommend that once you have your BSP ready, configured, that you run a CVE test over it. It's actually a scan of the Linux OS to figure out known common vulnerabilities and exposures if you are affected with your BSP. So what we do is if you provide your board to us and your operating system, we can do a specific scan of your BSP and then give you recommendations for actions and provide patches to fix the vulnerabilities for your board. Or if you're using SLCM, we can do it for you as well. So then the next topic is update and device management. You will need a tool to update your device. There are multiple tools out there. We have chosen, for example, RAUC and hawkBit as a free solution, which is pre-installed in our operating system and continuously maintained. You can see the feature richness of it here. And it's a self-hosted system, so you will have to create an IT infrastructure to host this hawkBit server to connect to your devices out in the field. But as we are presenting today, we also have the IoT-Device-Suite from connagtive, which is a more sophisticated solution with everything already prepared, so you don't have to host it yourself. This is a hosted service, and it has a lot of features which will help you manage your devices and update them, but also to maintain connection to your device when you want to, for example, get access to it and make changes and so on. So there's a lot of features Roland will show you. So just a quick overview of the features: access management, health monitoring of the device, of course, the software updates, and the maintenance of the device are some of the major features. And from Phytec, we also provide the provisioning service. This is activation of the secure features on an embedded device. For example, the injection of keys and certificates, for example, for authentication of edge devices to the update server, as I already mentioned. Well, why do you need provisioning? Well, the keys and certificates that are needed when they are injected this needs to happen in a secure environment. Since this process is the only situation where the secrets are actually exposed. So this needs to happen in a secure area, and Phytec has such an area in their production facilities with restricted access and no internet connection, of course. And there, all these secure features can be activated, and keys can be injected. And so, for example, JTAG can be deactivated, which will then ensure that the device is not accessible through debug interfaces and so on. Yeah, and we packed this all up in some security packages, I can say. It's an offering where Basic is the free offering that you get whenever you buy a SOM from us. You get the prepared Linux operating system with all the secure features already prepared and pre-configured. You get the RAUC and hawkBit client with explanation on how to set it up, and you get CV testing of our standard BSP. With the advanced offerings, we support you professionally in setting up the operating system, and we also do the device initialization to inject any keys if you need that. And we can help you configure the RAUC client or hawkBit, for example. And of course, we can scan your operating system for common vulnerabilities in a deeper manner. But this is not worth much because it's just a one-shot security mechanism, right? As I've already explained, what you actually need is a maintained security. So this is also an offering that we provide where we can continuously maintain your BSP, the device initialization. We then recommend a professional service like IoT-Device-Suite to update your devices, and we then offer the software lifecycle management to maintain your BSP, and then a prime cyclic review of your operating system. Everything is individually selectable. We did this because it gives a good overview of what you actually need for security. And yeah, just to give you some numbers, the maintained offering, for example, is about between 30 and 40,000 euros a year, which is an overviewable amount, I think. For what you get, actually you get a fully maintained BSP and a fully maintained embedded device in terms of security. So yes, now it's time to pass on to Roland. He will show you his IoT device suite solution and also explain a little bit more about the concepts for update and device management.
So yeah, thanks, Yves. I will also, I'm grateful that we can do this webinar together. Today we will do software updates for the boards here beside me. And I will show you a little bit of our GUI, of our dashboard, how you can do this. And let's start with also from me, a very quick introduction of what we do and what our mission is. So OSB Connective, we are also securing embedded devices. We started with devices that are actually on the field, so like on tractors or implements. And there we have had many projects having devices nearly everywhere around the world. So in Brazil, America, North America, South America, as well as also in Eastern Europe. And for sure also Germany, which is has quite harsh connectivity conditions. The company OSB Connective, we have a history that goes back roughly 20 years ago. My embedded security team, we have a history of 5 years now. So we are the embedded security and IoT business division. And as you can see, so we are 25 people, mainly in the Munich area, and also having an office in Sarajevo. What I will talk about today is software updating. I will talk about it in general. Especially I will talk about RAUC and hawkBit as one option that you could choose. So there are multiple others out there. There's not enough time to do this all right now. But I will show you how it's working. I will show you also how the connection is between RAUC and hawkBit and the IoT suite. So what's actually our offering that makes it easier to update the devices. And then I will do a technical presentation of how it looks actually. As Yves already said, so Phytec is offering a lot of security features. And this slide here should give you an overview of the life cycle from a security perspective. So if you develop a product that should be secure and that's connected to the internet, then you have like a V model in the beginning. You have you have an initial risk analysis, you have an architecture, you will derive your system or create the system that it's secure. But then you need some like continuous operations. For example, this maintained BSP. So you will like every week or every 1 or 2 weeks, you should create your BSP again. You should check it again for CVEs. And as well as also the hardening topic the provisioning of security features on the SOMs. This also needs to be done. And the best option actually is to let this be done by Phytec. And after this enabling like secure boot and all these features, there's another question. How can I get all these configurations, certificates, and keys on the device that each device needs to have connection to an endpoint later? So you want to send data to some endpoint, and these configurations, they are unique per device. So this is not something that should be in your firmware image. It's something individual per device. And here, Phytec and we have managed to have a PKI structure, so that we can create certificates for each device individually. And this helps us to onboard the devices automatically to our system. And then from this secure link, we can also send the configurations and the individual keys to your backend systems afterwards over the air. And let's say you have your maintained BSPs from Phytec, or you do it yourself. And the question is, okay, how do you roll this out? And in the IoT suite, we have a lot of modular features. One very important one is the software updating mechanism, which I will explain later much in detail. But we also have a secure remote access feature that you can log in via SSH or VPN connections to your device in terms of error, or maybe if you're in the POC phase where this might be very helpful. We do monitoring of health and security of your device, which is also important for the overall security concept, that you monitor whether everything's all right or whether your device might be hacked already. We have also a service to send individual configuration files, or just any file, anything that you can make a file from, we can put to the device if the device is online or not at the moment. So it's a queuing mechanism, and then you can use this to maintain your devices and configuration files, for example. The same we offer for executing commands or routines on your device. So also this can be scheduled, and then whenever your device is up and online, it will do what you wanted it to do. One very interesting thing is, so let's say you have you developed a new algorithm, and now your product is much better if you would have this new algorithm. So why not make money with it? So with software updates and with a feature activation service, you could say, okay, you have already the hardware, but now if you if you have a special license, your hardware can do much more. This is also one of the services that we offer, so that you have a secure feature or license activation service that you can use to do aftermarket sales, for example. But let's also start. So I think Yves already mentioned some reasons, but let me quickly tell also 2 reasons for software over the air. So why do you want to do this? As I also said with the features, so your product will improve over time. So I would say maybe 70% of the new features or new products, I think 70% of whatever the user will get afterwards is software. It's not only the hardware. So with software, you can do a lot of things. And if you improve the software, if you make it quicker, if you have more features, this is, it's a benefit to your customers. And if you have a way to bring this benefit to your customers over the air, this is the desired situation. And one company does this quite good. So Tesla, I think you know it. So they ship the cars even though they don't have the software that should be on the car when it's reaching the customer. So one good example also how you can save time to market. You can already produce hardware, but you will later also deliver the software to your hardware. And another important reason is security. So there are many reasons why you would want to do this yourself, but also there are some regulatory needs in some industries. So here, software update mechanism, a secure software update mechanism is, I think one of the lowest hanging fruit that you can find there. To put this into some requirements for software updates. So and also depending on the industry that you're in. So some requirements might be more important to your industry than others. Let's have fast updates, for example. So if you have a machine and during an update, it needs to have a downtime. So then this downtime should be minimal or maybe not existing at all. So like a quick switch over, for example. You also want to have multiple update channels. So over-the-air updates are great. But what's going on if your modem is broken or you have a software bug that then later prevents your device from working? So here, this is one of the things why you would also like to do a software update via USB or Wi-Fi or whatever. Cost effectiveness is also important. So if you think of over-the-air updates, then you have over-the-air connection or traffic costs. So they should be also minimal. So if you only need to patch a file, then you don't want to send a 100 megabyte full image to the device. So this is something where you have to have a good concept for. Safety is also important. So let's think about your device. So it's remote somewhere in the world, and nobody can really access the device via USB. So if you do an update, you want to be sure that it's really working. And if it's not working because you might have a software bug, then it should automatically roll back to the previous state where it was working still. So this is something very important. Maybe you also want to tailor this a little. Also this atomic that you see in the list here, what does atomic mean? This means like all or nothing approach. So you do not patch a single file or a single library. You patch everything or nothing, because then you have the ability to test everything before. So you have a certain test setup with everything fixed, all the applications in the right version. And then you can be sure that you have a validated system. And later you also want to just switch from one state to another, but not have like everything in between. So changing one application one by one. And for security, there are several requirements. So here just some of them. So authenticity of an update package. This is, I would say, the most important thing. So because if you would not have a check here that the software is coming from you or was digitally signed by you, then everybody could change the software. Maybe, like I said, these features that you could enable. If you just find the bit in the binary, flip the bit, and then you have your feature without paying for it. If it would be digitally signed, then this would not work so easily. For IP protection, this is that also reverse engineering protection of your firmware. Then you would also need to have encryption. Rollback protection, this means if you have a software update and it has a vulnerability, and then you patch this, you roll out new software to it. Then you also want that you cannot upload old software to the device, because this would mean you can bring it into this vulnerable state again. So this would be a rollback protection mechanism. And maybe you also would like to have everything open source, because then you know what you have in your system and can review it. And so these were all requirements for software update for one device. But if you also now look at fleets of devices, so you have many, many devices, then something called software update management system is important. This is also in the automotive industry, mandatory right now for cybersecurity. And some of the features here would be that you can track the software status of all your devices out there, that you also have the CVE and patch management, like Yves said, so that you know from all your cars or all your embedded devices, what is how vulnerable, what has which patch level. And also you will need to have a lookup table where you can see the software bill of materials, so all the software packages that are part of one image, and that you can also trace, okay, what OpenSSL version 1 point something I do have in which devices, for example, so that you know then what you want to patch. I think this is not everything that you might want to have from a software update system, but it's a lot. And RAUC and hawkBit normally offer this, as I will show later. Another aspect or something that customers are asking is like, okay, how often do I need to have an update? Because this is also a financial decision. Yeah, if you do more updates, more frequent, then it will cost you more money. And so normally you have like 3 things in your on your device you might want to update. The bootloader, I would say, is normally updated the least frequent, and also it's kind of tricky, or it might be kind of tricky to update, because normally you have only one bootloader, and if that is broken, then you have a brick device. The operating system will be the thing that is updated the next more frequent. So here normally you would have update like every quarter or every month maybe, or maybe only 1 or 2 times a year, depending on your industry, depending on the security level that you want to reach. This might change. And also applications might or the frequency for the applications. This might change directly from your business, from your development team. So if you're in an ongoing development phase, then maybe in the beginning, when you bring your product to the market, you have maybe once a week, you have an update. But later, if your product is more stable, then this might be only once a month or so, or once a year. So just to have a rough estimation of what you might expect. Now let's come to the so-called types of updates. So there are different ways how you can update an embedded device, or actually a computer. You can do application updates. This is something that you might know from Debian, from Ubuntu, from Red Hat. They all have package managers, and you can install one package. And inside of a package, you have a dependency list. And if this list is fulfilled, then you can install the new version of the package. Simple as that. But this would not be a real atomic update. So here you just patch one application, and all the rest of the system will stay in the same setup. And also, if this process is is breaking somehow, maybe because you lose power during update, then it might also be that you have some kind of a damage in your system. One very common approach nowadays is to put applications into containers. Once, because it's easier to handle the external interfaces, but also one reason is security. So you can decouple your applications from the operating system and from each other. So applications or containers can also be updated, but this is also not what I will show here later. If you want to know about these things, we can also help you. And there's also the option that you can do file-based updates. So this you can think of like something like a Git checkout or something like this. You can also do on your embedded device and change file by file, maybe with a reversion system or not. And what's also, I would say, the most, or one of the safest approaches here would be file system image-based updates. So you can think of it like you have a whole partition that will be updated. And here, as I said, so you also want to reduce the transaction costs. So you do not want to send the whole partition to the device because it's quite big. So root file system might be between, I would say, 30 and 70 megabytes roughly. You don't want to send everything, but also here, even though you change the whole partition, it might be that you do not need to transfer the whole partition to the device. And there are also mechanisms in RAUC that nowadays can do this. So in the following, I will talk only about this file system image-based updates. The other ones cannot be covered in this webinar. Maybe we will have another one on this. But also here you have a lot of options that you can do, and mainly they are trade-offs for your embedded device that you need to consider what's the best for your purpose. What you will always need is a bootloader, a root file system, and your applications. And normally you also have part of configuration, storage in your file system, some persistent things that will endure also during updates. So this is something that will not be touched during an update normally. And then you would mirror your system. So you would have exactly 2 root file system partitions. You have 2 application file system partitions, and maybe for every application, maybe 1 partition. So that you end up with 20 partitions at the end. This might be no problem. And this is called symmetric or double copy or double memory update scheme. And in this case, you have the benefit or the safety that you have one system A, for example, is running, and the system B is just there. So it's not running, it's not used at the moment. But if you do an update, you can flash system B. You still run on system A, and then after next reboot, the bootloader will decide, okay, now it's time to boot system B, for example. If you, so normally embedded devices are resource constrained. So normally you don't have just not enough storage. If you have a big application, you cannot just double it. You cannot just, use how many memory you would like to have. then one option might be this. It's asymmetric update system. So it's called, so you see, you only have one application and one root file system partition, but you have a rescue system. And this rescue system is very small, and it has the minimal things that you need to do software updates with it. So how would a software update work here? While you're running in the root file system, you get a trigger that there's an update going on. Maybe you download it to your config or data partition. Then you will tell the bootloader, hey, restart and boot the rescue system. And then the rescue system will take over. It will receive this update trigger. It will override everything that's in root file system and application file system. And then it hopefully boots root file system and application file system afterwards. But if this would fail, you cannot swap back to the old system. Then you could only swap to the rescue system. And another thing which would be even more or safer in safety aspects would be a mixture of both. So here you see, in this case, I just reduced the config partition a little. And now we would have enough space for 2 root file systems, 2 application file systems, and 1 recovery system. So in this case, even if both update slots would fail, then you would still be able to do software updates locally. So this would be the highest safety, but also it reduces the usable storage for you a little bit more. So I already explained it a little bit now in 1 or 2 slides here. How does it work? So you deliver your software update package. It's called RAUC bundle in this case when we're using RAUC, and it has the application file system. It has a root file application and root file system. It has a manifest, which will tell which software version number it is. It will tell you also the compatible things, so whether it's compatible for this board or not. And it has a signature for security, as I already told. And it does not matter how this thing is coming to your device. So it can be USB, local network, from via Wi-Fi or Bluetooth, or from the hawkBit server. So this does not matter to RAUC. This package is always the same. You will tell the device, hey, here's an update for you, please install it. And currently you see system A is booted, it's active, and then it's doing a RAUC install. So it's overwriting everything that's in application partition B and root file system B. And then then it will mark the new partition as active. But in this state, so we will see this also later in the device. Now we are running on system A, but the system B is the active partition. So after a normal boot, system B would be booted. So this is kind of an heterogeneous state. And it's up to the user or to you to decide when do you do this reboot. Do you do it directly on the fly, or do you do it after signaling it to the customer? This is your choice. And after you've done the reboot, you then see, okay, device B is booted, and system B is booted, and you should have your new software. And this can be tailored, it can be extended. So here you see the full process loop. So you can have hooks before or after installation, with or without encryption, sanity checks at the end after installation. So this can be tweaked quite a lot. So I've done this as minimal as possible for this presentation. And so this was how the local installation is happening or working. Let's have a look, like what components do we need so that this is happening over the air. Yves already said, so there's hawkBit and there's RAUC, and there's the application, it's called RAUC hawkBit Updater. Actually, this is just the glue code client that is connecting to hawkBit, and then if hawkBit is signaling, hey, there's an update for you, it will fetch this update and it will install it locally. And this is fully open source. So this is not something that we did. The only thing that we do is we host this hawkBit server for you so that you do not need to take care. And the other very important thing is that the hawkBit server itself, it must know which devices are connected to it. And for each of these devices, you will also need to send a configuration file down to the device. So this is what we call onboarding. And this is what we fully do automatically for your devices. So once we have agreed with Phytec on the certificates and so on, once the device has power, electricity, and internet, it will automatically be registered to a hawkBit server. It will receive its config, and after this, the hawkBit server, the RAUC hawkBit updater will poll the hawkBit server and will do the updates. And if you don't, if you want to do this for like 100 or 1,000 devices, then you need to have some automated tools to do this. And this is one of our major things that we offer to our customers. Just quickly, how a software update package is created. So you have Phytec, or maybe you do it yourself to build this Yocto image, or your Linux image with the application and file system and root file system. You do some testing stage depending on your internal processes. You need to do bundling and signing, or maybe also encryption. So you need to have also keys to do that. This is also something that we offer as a service if you want this. Then we can do it in the cloud. And then you have your RAUC bundle. This bundle you can upload to the hawkBit server, and then you can deploy it to the device. And one of the major advantages of hawkBit is that you can roll out software in bunches. So you say, okay, maybe only 10 devices at a time or 100 devices at a time. And if it's failing, then you can stop it. So here you can really deploy the whole fleet, maybe only a fleet for a certain country or whatever. And this is what I will show you in 1 minute, I would say. So how we do this from our GUI, but only for one single device. One word that you can understand it a little bit better. So how is our architecture looking? So you have an embedded device here on the left, and on top of it, you have different applications that will talk to your endpoints, maybe where you want to put your data. And on the right, we have this yellow part is like our integration that we have already done for the Phytec boards. We have one IoT client. It's communicating via MQTT and mutual TLS to our system. It's sending the health monitoring telemetry. And then we have this RAUC hawkBit client that will talk to hawkBit server. As well as we also have the remote access client, but this is not important for now. And to our customers, we offer everything that you can see or that you can use in our system via a GUI that I will show later, and also everything via an API. So you can integrate it into your ERP system or whatever you want, or your own tools. But now it's time to do a live demonstration. So on the left, you see, or maybe let's start on the left. So here you would see, 1 second, I need to get to the right screen. So this is a dashboard of one of our devices. So in this case, it's a telematics unit. So it has a SIM card. The board that I show here does not. So I will quickly walk you through the features that we have in our IoT-Device-Suite. So this shows like all the most important information about firmware, about the SIM card that's included. Also how the connectivity of the device is, so when it was communicating for the last time. You can write down some notes. So if you do maintenance or support for some devices, you can have your own remarks here. We have an integrated SIM management, so we can show information from the SIM portal of your choice. So we can also use it to enable and disable the SIM from just one GUI here. We retrieve health data from the device. So this is the monitoring that I've announced earlier. So we see the file systems, how they are used, RAM, CPU, and so on. Firmware, I will just skip because I show this for the demonstration board. Regarding remote access, so if you want to have an SSH connection to your device, we have one thing that we can offer is password management, so that you do not need to have one global root password, but that you can use one-time tokens. So for this, we have symmetric keys that we provision to the devices, and from these keys and timers or counters, we can create tokens that you can give your service personnel, and then they can log in only once with this token. And also for monitoring, we have everything that you do here is logged in the cloud, so you know what's happening, and you have an audit trail for security as well. We can, or you can send files to any place on the device. You can say, okay, so I want to put some reboot script, place it in the bin folder. You can upload it and trigger it to be sent to the device. This is also secured by a whitelist, so you are only allowed to download things that are previously allowed or explicitly allowed, and as well as any Linux command that you would like to execute on the device, you can do with our system. So you can specify the command and then schedule this to one or to all the devices or to many devices as you want. This license rollout is a feature which I already said before. So here you can enter some parameters and then send a license file to a device. It will come with a signature as well, so you can prove that it's authentic, and then a local application can activate or deactivate a certain feature, depending on whether this license is on the device or not. Also, a logging feature we have, so it's just a simple thing. So you can just log different messages, severity levels, and IDs. And even though the device might not be online all the time, then you log it locally in or you store it or buffer it locally on the device. And once it's connected again, you will see the messages here. So this might be very nice for debugging. And here we also show like the raw data that the device is sending over to us. And one of the most important things that you see here, this is the information of RAUC that I will show you for the demonstration kit here. So here, let's go to the firmware update slot tab. So there are two things that we do here. One is that we, two kinds of information where we get the information regarding software updates from. One is what the device itself knows about it. So locally there's a client on the device. It's asking RAUC, hey, what do you have installed at the moment? And this is what you see here. It's telling currently there's something installed. It's 5 hours ago. And we have a fallback slot. And because time is running a little, I will just trigger the next update. So let's have a look. So here there are some updates that I can trigger. I go to the log to see what happened here, and I see, okay, demo 1 was installed the last time and it succeeded. Now I will choose the demo, what was it, 2? 1. So I will need to install demo 2. This is this one here. So you see a lot of bundles are uploaded to the hawkBit server. So this is fetched in the background from the hawkBit, and I can trigger this to be deployed to the device. And now the hawkBit server received this update trigger, and and also what we can see here. So here currently nothing is changing. So the device is still in this slot 1 state. So slot 1 is the active state. It was installed 5 hours ago, and the fallback slot is something that was updated yesterday.
And the LED is still blinking blue, so that's also
exactly, yeah, on the right. So because software updates is very hard to indicate. So here you see blue means slot 1 is active, and later it should be green. It's hard to see. Maybe I can switch a little bit with the lighting here, so now it's see a little bit better that it's blue. And when it would be red, this would mean we are in this intermediate state where the update was succeeded, and but the device did not reboot. And let's have a look here whether the device already received the update trigger. Okay, so it's quite long. Or so you see, okay, here the update was started a minute ago, and it already downloaded everything, and it's about to copy everything to the root file system. So you see all the log messages that RAUC is locally telling. So every of these steps are reported by RAUC, and then RAUC reports, or RAUC hawkBit updater reports this to the hawkBit server. And okay, and on the right, you see already in the device, I think now the blinking is much more red than it was before. So yeah, here you see also the software bundle was installed successful. Let me quickly remove power. So now I power off the device. Now I've powered it again. And after a minute or so, the device should reconnect to the system. And yeah, then it should be, the active slot should be slot 0. And I had already, I think currently it's blue, but let's see. So, okay, so here you see the reported state is 3 minutes ago. So it's not the recent update that you see here. So the information might be a little bit outdated. The IoT client that I told you before that is sending this information package to our backend, it's not continuously updating all the information. So it's normally firing every 5 or 30 minutes. So depending on how often you want to have your information refreshed. Still 3 minutes ago, so maybe it's not online yet.
Well, Roland, we have 7 questions. So
okay, then let's
go. Go for some questions. Huh?
Yeah.
Yeah. So, before we lose everybody, could I share my screen real quick, Roland?
Yep.
You can share it back real quick.
Maybe then, if you allow me, then I will just show some like next step slide here. So we have this kit that I just showed. You can get this. So this will be also, I think, mailed to you, this information. So where you can get this, how you can get started, so how the onboarding is working, how you get your own account in the IoT-Suite and so on. And also maybe one information from my side. So if you need any more, if you have any questions to other update systems, how it's for your device working, whether you need some ideas, you can also ask Phytec or us for expert talks. So you will find ours in the contact section of our IoT-Suite.io page. And then we can have maybe a more technical discussion. But then over to you.
Yeah, so you actually did the same thing. You showed the kit that you can order. Let me just share the screen real quick. Here we go. This is how you can order the kit, and you can try out what Roland just showed you exactly in the same way. It's a pre-installed RAUC client that will communicate with IoT-Suite, and we have a quick start that explains how to get started. Yeah, so Roland, I think we could go through the first question if you like. Should I read it out for you?
Yep.
Finally, your infrastructure supports one of the standard package manager. For example, is it possible to keep the system up to date using apt?
Yeah, so here I would say yes and no. You could design a system that would be capable to do updates via RAUC or file system based, plus also having Debian packet manager. This might be possible. The question is whether it's a good idea or not, but this depends on your use case. So you could, for example, just download a Debian packet to your device and install it locally. And if you're sure that nothing will break, then it's also fine.
Okay.
Might be an option. Yeah.
Next question, how to switch between system A and system B or rescue file system if it requires some serial connections to change and knowledge to do it. For example, not the farmer, then operator engineer can just refresh device. So why for? So I think what the question is, how does the system know to switch between A or B?
Mm-hmm. So normally this switch is triggered by by a routine on the device. So it's called RAUC mark active, and then you decide which slot should be active. Or you can say RAUC and switch, and then it will mark the next slot to be booted. So normally the switching is triggered at the end of the update. So this switch command, and after the next power cycle, it should switch. You can also say that you do this locally if you have a GUI on your embedded device, and you can click on a button and then maybe this will trigger the switch. So this might be one option. Switching it from the command line is not an option normally. So normally the bootloader should be secured as well. So this should not be the target to go for if it's a secured system. Mm-hmm. But you can design this in any flavor that you need this in your industry.
So you could add in your update script that after everything has been updated, the system should do a soft reset and update itself after the reset.
Exactly, but sometimes you might not want to have this because you do not want to lose the customer. So if he does not acknowledge, then maybe the system is offline and nobody knows why.
Or maybe it's just a suggestion that the customer gets. If you want to update now, please press button or something like that. That's maybe the better way, right?
Exactly, and then he might be also surprised how quick the update will go because it's just a switching and reboot.
It's already there, yeah. No. And then next question, automated rollback, how it works. For example, device stop working after update, how device will initiate automated rollback. If it requires operator, it's not automated. Operator can just reflash the device.
Sure.
No, go ahead. You will.
Yeah, so it's also kind of easy. So in the bootloader, you have several variables. And these variables count how many times you have booted a system or how many tries you have left to boot a system. You can configure this to be starting at any number that you want. Normally it's 3. And so when a system is booted, like system A is the next booted system, then currently it has 3 attempts left. This will be decremented by the first try. And if all attempts are gone, so let's say it's booting and nobody is resetting this value again to 3, then after 3 attempts, it would be not booting again from system A, but it would switch over to system.
Thank you.
And but who is resetting this? So this is a so-called sanity script that's normally started at the beginning of the boot or after the boot is successful. You decide when successful is, and then you reset this value to 3, this counter value, and then everything's all right. So actually, it's booting, it's decrementing a value, and if your system is not coming up again, then nobody is resetting this value to 3. So you will lose your attempts, and after you have lost all your attempts, you will go to the next slot that is bootable. And if this is also failing, maybe, then you go to the rescue system and stay there.
Let me ask another way.
Yeah, okay.
I'm creating application. I have root file system. I have application. I create some new application. Is it always a full root file system with my application, or it goes as a package?
There are various ways how you can do this. So you can, for example, only update one application, like your application partition. Then you don't need to update your root file system. This might have other challenges then. But also with RAUC, it's possible that you need to create everything. So root file system plus your application, like having, again, 100 megabytes. But then in this transmission phase, RAUC will detect what it already has and what files did not change, and it will only download the difference.
Okay, I see.
This is also possible.
Yeah, but I'm always building everything, right?
Normally, yes.
Okay.
But actually, this is a recommendation. So you could also say, like, I have a binary and I just want to send the binary as a file to the device and use it there. This is also possible, but it's not so safe, I would say. So if this might break somewhere.
Okay.
Next question. Thanks for the presentation. You're welcome. Is it also possible to update additional microcontrollers as well with the software?
Yes and no. So it's not out of the box. So what our GUI is currently offering, or RAUC is offering, is mainly updating Linux devices. But we also have some application or actually what you need is an application that will check for all your devices that are connected after your Linux device. And then you need to have an update routine for this. So if you have all these things, then you can deploy the packages to your Linux machine, and then the Linux machine is taking on the updates, as well as also receiving the information of how these updates went and so on. So this is something that we also have. So if you have really a need for this, just get in touch with us and then we can talk about it.
Next question, very good question. Is something as OS tree possible? If I have only a small bandwidth, it is not possible for me to make AB updates.
Yes, it's possible. Yeah, sure. And it's one of the like file system based or file based update mechanisms. Yeah, it has also its strengths, and yeah,
Okay.
Might be an option.
Good. If you disable the SIM remotely, for example, just one mistake, what is the way to enable it again? For example, devices out in the field.
Yeah, so this is something that's in our system, it's quite cool. So when the device is onboarded, we get the SIM ID transmitted to our backend. So we know what SIM is included there, and then we can remotely activate or deactivate it. So if whoever customer is now having an issue, he needs to tell us. Yeah, so he needs to tell, hey, my SIM seems not to work. Maybe he has an indication light for this, and then we can remotely activate it. But it's normally not us that are doing it, but it's our customers. So our customers mainly are OEMs, and they have the full access to these features, or they can also use it from their enterprise resource management programs. So they can also update it from SAP system. Yeah.
Next question. If we're talking about all this ecosystem, what is the monthly traffic without updates?
Good question. So it's depending on your usage. So I told that we have 3 applications running there. So one is sending telemetry data to us. So this is roughly, I think, for 30 minutes. So if you send a data package every 30 minutes, then it is roughly, I think, 10 megabytes a month. I'm not sure. Need to look this up. But yeah, so in this range, so it can be between 10 and 50 megabytes, I guess. But you can also decrease this. So if you say, okay, I only transmit this data once after boot, and this is enough for me, then it's also fine. Or yeah.
Maybe it's a good idea to mention that, Roland, you have a calculating tool on your website, right? So customers can calculate their own scenario and adjust the values, and then they can see what the pricing becomes, right?
Exactly, but this does not include the total SIM traffic also. So this is only there we can calculate the price for our services. So this is also depending on the amount of connection attempts that you do with our system. So this is one factor in the pricing. Yeah, but if you need some special things, so we can also do monitoring. We can do from the SIM cards that we have. We can also do traffic logs, and then we can identify to which systems your device is communicating, like how many megabytes to which IP. If you know to which URL they belong, then you know completely what you can optimize.
So the calculation tool shows you all the costs of the system, but not the SIM card costs, because those are separate, right?
Exactly, but they are in our normal price list, so they can also ask for it.
Okay. And last but not least, why don't you use an existing package manager to deploy packages? I'm talking only about deploy, distribute software, not about all infrastructure. From my point of view, one of the existing package managers does the process easier, more than we can easily update packages one by one, including configuration. And all that you need just FTP or HTTP server.
Yeah, so I would say safety is one of the main reasons here, and also the communication and electrical situation on your devices. If you have a 24/7 running system with a good internet connection and how's it called, USB in German, ausfallsichere Stromversorgung, then then you can do maybe a Debian or package management things and don't need to worry. But so when we designed this system also with RAUC and hawkBit, we could all the time have power failures because we are on a tractor. So somebody is putting out the ignition, then we have total power loss directly. We can also have internet connection disrupting all the time. So, and all these things are not really, so these package managers are not optimized for this. And we did a lot of things that we could do software updates in Brazil, for example, with kilobits of data. And we did updates that downloaded 2 months. Yeah, and this I think would not have been working with a normal package manager. So there are some reasons you can use package managers in like normal Linux machines with good internet and electric conditions, I would say. But for real fail-safe operation, I would rather tell something like RAUC would be a better choice.
And maybe from my experience, what is also an advantage in comparison to package managers is using a Yocto system to really have a recreative system. So once you compile you configure your Yocto image, and then you compile it, and you create the binaries out of it, and then you update that, you can always recreate exactly this configuration. And you will always know what package is inside and which one is not inside, and so on. With an automated package manager that will download from a certain repository that you may be maintaining, you never know the exact state of each device. And there might be conflicts. One device might have the package, the other device may not have it, and so on. And so with Yocto, building your image every time you need to make a change does have the advantage that you have an atomic update, and you will always have a reproducible system. This is especially important if you are looking for errors and things like that. So yeah, I think that's another advantage.
As well as it might also be smaller. So depending on your resource consumption. So if you have anything on a big SD card or big flash, then it's not a problem. But if you have only internal flash, then the Yocto system or build root system will be much smaller than like a tailored Debian normally.
Yeah. Okay. So I think that's it for all the questions we got from the QA. Looking at the questions, I mean, we got 9 questions. Thank you very much for these questions. It shows us that there's an interest for what we are presenting, and I hope you enjoyed the presentation, and you learned a lot from especially Roland's presentation, where he showed you a lot of internals, technical internals, which is great. Thank you, Roland, also. As we already mentioned, and we have it here shown on the screen, you can visit phytec.de and go to the Phytec online shop, and you can order the update and device management kit. And yeah, I think the code is UDM -25, and you get 25% discount. So yeah, if you want to try it out, don't feel afraid, just go ahead and purchase it. If you just want to have more discussions, also not a problem. Just contact our sales team and ask them for an expert training, and we will contact you, and we can have another hour for free just to talk about what the features are and what the offerings are. Yeah, I think that's pretty much it for today. If there's no more questions, I wish you a good evening, and see you hopefully next time in the next presentation or a personal meeting and an expert meeting. Yeah. Roland, thank you as well.
Yep. Thank you as well. And yeah, maybe see you next time with another security aspect.
Okay.
Looking forward to it.
Yes.
Bye. I hope you enjoyed this webinar. We are constantly creating webinars, tutorials, training videos for embedded systems and IoT security. Leave your subscription, give us any comments or feedback, or any topic that you would like to hear something about. I am happy about your feedback. Thank you, and be secure.